multi-step question. Acetone has a density of 0.786 grams per mils and a heat of combustion of 428 kilocalories per mole. What is the complete equation for the combustion of propanone? How much heat in kilojoules is released if 2.58 grams of propanone reacts with oxygen? How many grams of oxygen gas are needed to react with 15 mils of propanone? And how many liters of carbon dioxide are produced in STP in part C, so standard temperature and pressure. Okay, so let's start off. I believe this is question 10. So 10A is to first write the complete equation for the combustion of propanone. So propanone is a 3-membered carbon chain that contains a ketone group. Oops. I'll just draw it like this. That contains a ketone group in the middle. And it is known as C3H6O. So I'll just label this as propanone. And when we have a combustion reaction, this is reacted with oxygen gas, and the products are water plus carbon dioxide. So when balancing out this equation, we first need to balance out our carbons. So we have 3 carbons on our reactant side, so we need 3 carbons in our product side. So I put a 3 in front of CO2. And next I like to balance out my hydrogens. So we have 6 hydrogens in our reactant side. So I need to put a coefficient of 3 in front of the H2O. And finally, we'll balance out our oxygens. So on our product side, we now have 6 plus CO2. Oh wait, so 3 plus 6, so 9. And we only have 3 on our reactant side. So to make 9 oxygens on our reactant side, if I put a 4 in front of O2, then this should balance out my reaction. So this was part A. And for part B, we want to know how much heat in kilojoules is released if 2.58 grams of propanone reacts with oxygen. So we know the mass of the propanone is 2.58 grams. And we first need to calculate the molar mass of propanone as well. So the molar mass of propanone will be 3 times the molar mass of carbon, plus 6 times the molar mass of hydrogen, plus the molar mass of oxygen. So these values are just found on your periodic table. So for carbon, it's 12.01 grams per mole. Hydrogens is 1.01 grams per mole. And oxygen is around 16. And you should end up with a molar mass of 58 grams per mole. Okay, so we have our mass and our molar mass. And the next part is to calculate the number of moles. So number of moles is equal to mass divided by molar mass. So we just need to plug in our values. 2.58 grams divided by 58 grams per mole gives us 0.44 moles of propanone. So to calculate heat, we know that the heat of combustion is 428 kilocalories per mole. So since we're given the number of moles, all we need to do is multiply these two values. So I can say that heat is equal to 428 kilocalories per mole. And we just need to multiply this by our number of moles. And the moles will cancel out. And we get heat equal to 19.04 kilocalories. And the answer wants us to give it in kilojoules, or the question wants us to give it in kilojoules. So we just need to multiply by the conversion factor, which is 4.184 kilojoules per kilocal. And our final answer is 79.66 kilojoules. Okay, so that was part B. Part C asks how many grams of oxygen gas are needed to react with 15 milliliters of propanone. So if we recall the density equation, which I'll write up here, density is equal to mass over volume. So if we rearrange this equation, then we can solve for the mass of propanone that reacts with oxygen gas. So I'll just write here that mass is equal to density times volume. So the density was given in the equation. It was 0.786 grams per milliliter. And our volume of propanone was 15 milliliters. So now our milliliters will cancel out, and we know our mass of propanone now, which is 11.79 grams. So now that we have our grams of propanone, we need to calculate its number of moles. So again, number of moles is equal to mass over molar mass. So our mass is 11.79 grams. Our molar mass we found in the previous question. It's 58 grams per mole. And we get 0.2 moles of propanone. So from here, we can use molar ratios to find the moles of oxygen gas that reacts with 0.2 moles of propanone. So by using our balanced equation that we found in the first question, we can multiply this by the molar ratio. So we know that 4 moles of oxygen is needed to react with 1 mole of propanone. So if we multiply 0.2 by 4, then we get around 0.8 moles of O2. And finally, we can calculate the mass of O2 by multiplying these number of moles by O2's molar mass. So 0.8 moles of O2. And the molar mass of O2 is 32 grams per mole. So then we get, let me calculate this here. 0.8 times 32, around 25.6 grams of oxygen. Let me circle our answers. This was the answer for part 2. And now we can answer part D, which is how many liters of carbon dioxide are produced in a standard temperature and pressure in part C. So again, we know we have 0.2 moles of propanone, and we can multiply by the molar ratio of carbon dioxide and the propanone to get the number of moles of carbon dioxide. So 3 moles of CO2 reacts with 1 mole of propanone, and we also want to take into account the molar volume of a gas at standard temperature and pressure, which is 22.4 liters. So we multiply this whole thing by 22.4 liters, which I'll put in brackets, is molar volume at STP. And our final answer would then be 13.7 liters of CO2. Okay, so again, this was a multi-step question, and it's a good question to ask on like a midterm or an exam because it touches upon so many different topics. So for part A, they balance the equation. So 1 propanone plus 4 O2 makes 3 CO2 plus 3 water. The mass of the sample is 2.58. They converted to kilojoules first, which is also what you can do for this question. And they found the molar mass to be 58 grams per mole. And they also got 79.5 kilojoules of heat. For part C, they have the volume of the sample, the molar mass, and the density. But here they said that the molar mass of oxygen is 16 grams per mole. So they used 16 instead of 32, and they got 13 grams of O2. So it's pretty much the same as ours, except divided by 2. So I'm just going to take note that they could also use the molar mass of oxygen gas, which was O2. But the approach is still correct. And then in part D, they wrote down what was given, and they summed up how to find the number of moles of propanone again, divided it by 58.1, and then multiplied it by 3, and then they plugged it into the ideal gas law. So this gives the same answer, which is 13.6 or 7, so that part is still correct. So this solution is correct. Great job. However, okay, the approach for part C was also correct. However, the molar mass can be for O2, which is 32 grams per mole, giving a final answer of 25.6 grams of O2 instead of 13 grams. Yep, so they just multiplied by a single atom of oxygen, which was 16 grams per mole. But if you wanted to do diatomic oxygen, you multiply by 32 grams per mole. Okay, but this solution is still correct. Okay, so those are all the questions for this session. And if you enjoyed today's Q&A and you'd like to be notified of when we do this next, please hit the subscribe button and notification bell below. If you'd like to submit a question of your own, then check out the links in the description. Also, if you enjoyed today's video, you can give it a thumbs up and a comment, or you can share with your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye.